Welcome back to another exciting chemistry lesson. Now, first of all, we learned that most reactions require multiple steps. And then we just learned that at equilibrium, we have something called equilibrium constant. So each one of those reactions has its own equilibrium steps. So what happens when we combine them together? What happens when we manipulate a chemical reaction at equilibrium? There are three rules that we have to memorize. The first one is that if the new balance equation is multiplied by a number, okay, that's going to change the coefficient, okay, we are going to raise the original k to that number as well. So, but one thing you have to remember that is that if we have times 10 to the number and that raised to the new number, this two number right here is multiplied together. So that's one thing you have to be very careful, okay, is when you have power raised to another power, they multiply together. So it's not the same thing as 10 to the power of this number. No, be careful with that part. Now, the rule number two, if the balance equation is reversed, that means the product becomes the reactant. So product become reactant, okay? What we need to do is that we are going to take the inverse 1 over the original k, okay? See that? So 1 over. And we're going to see this in action in a few minutes. And last rule is that if we are combining the equation together, okay, we're combining other equations together, the new k is the multiplication of all k, okay? So those are the three rules. Let's look at them and see how they are in action. So here we have the values of equilibrium for this reaction above. This one right here is 1 times 10 to the 6th power. What is the values of the equilibrium constant for the following reaction? We are going to, in this case, see that this become that. So how is that possible? Well, first of all, we have SiCl4. It is in the product side, but all of a sudden it becomes the reactant. So what does that tell you? We just take the inverse of K. See that? Okay. See that? We see how to take the inverse. Not only that, notice how we have 0 coefficient here. Well, 1, of course. And now this become 2. This become 2. And this become 4. See how they double? So that means we're just going to double everything. So therefore, we are going to raise to the power of 2. See that? First, we take the inverse, then we double. Either way, it works as well. If you do this, we can take k over 2 and over that. Same thing, okay? So how would that work in terms of plugging the values? Well, all we have to do is just plug in the value. 1, okay? 1 times 10 to the 6th power to the 2nd power. Ooh, that's easy. 1, okay? 1 times 10 to the, well, 6 times 2 is what? 6 times 2 is equal to 12. Okay, I'm going to show you all the work there, so that way you don't get confused. 1 times 10 to the 12. Now, sometimes they're going to try and trick you. They're going to put you in this format. Everything as a single number, not as a fraction. So how would you bring this up? Well, whenever you bring it up, whenever you switch from top to bottom, the exponent change, right? Take the opposite sign. So therefore, 1 times 10 to the negative 12. And that is all we have to do. And if we type this in here, we have 1 times 10 to the negative 12. See that? So don't get tricked, because a lot of time they do this in multiple choice and they put in this different format instead of just the answer itself. Let's try another problem. Here we have two reactions, and we want to make sure that when they combine, they have something like this. So let's look at this, okay? Well, look at our 2FeO. Where's that? Oh, it's right here. Okay, so it's on the reactant. The coefficients stay the same. So pretty much we don't do anything there. And 2Fe, 2Fe, O2, and O2. Ooh, O2 is no longer here, okay? So we have that. But for now, let's go on to the next one. So O2 get canceled somehow, okay? So over here we have CO2. Look at that, CO2 from reactant all the way to the product. So that means we are going to switch, okay? So we're switching that part right there. So that means we are going to take 1 over K. See that? So if that's the case, what we have C plus O2, okay, CO2. Look what happened to O2. It cancels out. Beautiful. And it gives us C right there. Okay, so that's all we have to do. Now we just combine them together. Let's assume this is K1, this is K2, okay? So this is 1 over K2. So all we have to do is multiply K1 times K2, but the new K2 is right here, okay? So 1 over K2. There you go. Isn't that nice? Let's plug it in. In a way, if I want to do this, I can have K1 over K2. See that? So just to illustrate to you how they can manipulate the answer to trick you. So let's plug it in. 1 times 10 to the negative 4, okay, divided by 1 times 10 to the 6. Now, remember when we talk about when we bring this up, we just take the opposite of it. So all you have to do is this. 1 times 10 to the negative 4, okay, times 10 to the negative 6. And look at that. The same base, what happened? You add them together. 1 times 10 to the negative 10. There you go. And we type this in our answer right here. 1 times 10 to the negative 10. So that is how you combine or manipulate equilibrium constant based on the new chemical reaction that's given to us. So again, take the time to write out the answer and show your work if you struggle with this problem. And if you have any question, definitely take a picture of your work, put in the forum, and we'll see you next time on another exciting chemistry lesson.